and welcome back to Wired-Tec. In our last explainer, we managed to get these incredibly powerful computers onto our desks, but they were all on their own, like little digital islands. Today, we're telling the story of how we built the bridges between them, creating this connected world that, let's be honest, we all take for granted now. Let's get right into it.
So, just to recap, we left off in the middle of the personal computer revolution, right? Machines like the Apple II and the IBM PC had taken the computer from this massive, room-sized thing down to something you can actually have in your home or office. It was a huge leap forward.
But here's the catch. Each one of those computers was basically an island. Sure, it could run its own programs, it could crunch numbers, store your files, but it couldn't easily talk to the computer on the next desk, let alone one on the other side of the planet. And that leads us to the big question for today. How on earth did we connect all these islands?
Now, you might think this story starts in some garage in Silicon Valley, but you'd be wrong. It actually starts in the incredibly tense, high-stakes world of the Cold War. The goal wasn't fun or profit, it was pure survival. Okay, picture this. It's 1957. The Soviet Union just launched the Sputnik satellite, and the US military is, let's just say, on high alert. They looked at their own communication system and saw a huge, glaring weakness. It was all centralized. One well-placed nuclear bomb could completely wipe out their command and control. The mission was crystal clear: build a network that could not be killed. So the answer came from the military's Advanced Research Projects Agency, or ARPA, and their solution was called ARPANET. The whole thing was based on this brilliant idea from an engineer named Paul Baran. He said, let's build a distributed network. Instead of one central hub that all the information has to pass through, you build it like a web. If you knock out one part of the web, who cares? The messages just find another way around. And the technology that made this whole crazy idea work was called packet switching. It's such a cool concept. To make the network stronger, you don't send your information in one big piece. You actually break it apart. Think of it like this. Instead of mailing a whole book, you tear out every single page, put each page in its own separate envelope with the address, and mail them all individually.
So a big file gets chopped up into these tiny little data packets. Each one gets stamped with the final destination. And then they're just released onto the network to find their own way. They might take totally different paths, bounce all over the country. They might even arrive out of order. But that's okay because they're all numbered. And at the other end, the receiving computer just puts them back together in the right sequence. You can see why this was so resilient, right? A blown-up router is just a little detour for a few packets, not a total shutdown. And guess what? It worked. By 1969, the very first nodes of ARPANET were up and running, sending messages back and forth. For the very first time, these separate, isolated machines were actually talking to each other over a network with no single point of failure. The foundation for the internet had just been poured.
So, we had a network, a really powerful tool for the military and for university scientists. But for you and me, it was completely unusable. The next huge challenge was to build something friendly, something accessible, right on top of it.
You have to understand, the early internet wasn't a pretty place. There were no pictures, no clicks, no icons. It was a black screen where you had to type in these weird, cryptic commands to get anything done. It was powerful for sure, but it was only for engineers and academics who knew the secret language. It was a million miles from the internet we use every day.
And this brings us to a really important point that a lot of people mix up. The internet is not the World Wide Web. Think of it this way. The internet is the physical infrastructure, all the fiber optic cables, the routers, the servers all over the world. It's the roads. The World Wide Web, on the other hand, is the system of websites and pages and links that runs on top of the internet. The web is all the houses and shops and destinations you can visit using the roads. One is the hardware, the other is the software.
So how did we get this friendly web? Well, a couple of key things happened. First, back in 1974, a protocol called TCP/IP was created. You can think of it as a universal translator and a global postal service, all rolled into one. It became the common language that let all the different little networks talk to each other, creating a true network of networks. Then, in 1989, this British scientist at CERN named Tim Berners-Lee came up with a new way to organize information. He invented the World Wide Web, with its pages, its hyperlinks, and the very first web browser. And just like that, the internet finally had a face.
And it is really hard to overstate how important this was. For his invention, Tim Berners-Lee was given the AM Turing Prize, which is basically the Nobel Prize for computing. He single-handedly gave the world an easy, intuitive way to explore this massive ocean of information.
Okay, so We've connected the computers, and we've made the information accessible through the web, but there was still one big chain holding us back. You had to be sitting at a desk. The next great hurdle was to cut the cord and make all of this power mobile.
I mean, for most of the 90s and early 2000s, going online meant sitting down, firing up your big desktop PC, and listening to that awful screeching sound of a dial-up modem. The connected world was amazing, but it was a place you visited, not a thing you carried with you.
But then things started to move, and they moved fast. We had mobile phones, of course, but they were pretty much just for making calls. Then, in 2007, everything changed. Apple launched the first iPhone. And this wasn't just a phone with a clunky web browser. It was a genuinely powerful computer that just happened to fit in your pocket. A year later, the App Store opened, and that just unleashed a tidal wave of creativity that changed our relationship with software forever.
The genius of the iPhone was how it put all the pieces together so perfectly. It had a powerful processor, a beautiful touchscreen that you could actually use, and it gave you the real web, not some stripped-down mobile version. And then the App Store. It was like a gold rush for developers to create new and amazing things for this platform. That was the moment. That was when mobile computing really took over.
And hey, if you need any proof of its impact, you just have to look at the money. To this very day, the iPhone consistently makes up more than half of Apple's total revenue. It wasn't just another successful gadget. It was a cultural and economic phenomenon that completely redefined an industry and turned Apple into one of the most valuable companies on the planet.
So, we did it. We went from a Cold War survival network to a device that connects billions of us every single second of every day. It's an incredible journey. So let's quickly recap and see where we're headed next.
You know, when you lay it all out, it's pretty amazing. We started with a military need to build a network that could survive a nuclear war. That gave us ARPANET. Then, we built a friendly user interface on top of it called the World Wide Web. And finally, we cut the cord from the desk and put all of that power right into our pockets with the smartphone. The connected world is here. Billions of us are linked together. But the story of computing is far from over. In fact, we're starting to hit the fundamental physical limits of the silicon chips that have powered this entire revolution. So the big question we have to ask now is, what's next? What does computing even look like when it goes beyond silicon? We're going to dive into that in the final part of our series. Thanks for watching. If you enjoyed this, please hit that like button and be sure to subscribe to Wired-Tec so you don't miss our grand finale. See you next time.